Okay, guys, we're going to dive back into Recon, and then we're going to get our first lab in here in a few. So I know you guys are probably getting antsy to actually like open up a VM and do something. All right, so back to cloud asset discovery. So before you go and port scan a bunch of systems and go actually sending data to targets, check Shodan and Census. So both of these sites are what are considered internet-wide port scans. And they are constantly scanning everything on the internet for various services and provide you the ability to query that data. I mentioned the certificate transparency thing, right? So with Census, similar thing, right? You go search the domain name on Census, and a lot of times you can find that other TLD just by scrolling through the results from certificates that have a domain name. One pro tip: keep an eye on Shodan deals, because I've noticed I guess the normal member license is like $50 or $49. I have seen occasionally where they'll just throw it out for $1. So keep your eyes open for that. But Shodan's really awesome. Same thing with Census. The next part is straight up DNS brute forcing. Okay, so this is sometimes host names just don't show up in a search, and this could be a few different things, right? This could be that maybe the organization has some new things that haven't been categorized yet. This could be that maybe it's a name that is just not referenced anywhere, like on certain searches. So doing actual DNS brute forcing is kind of a necessity. But the biggest thing to keep in mind here is using good lists, okay? So what I mean by that is make sure you have quality lookup lists. So the SecList site here that I have listed has a number of those. This is from Daniel Meisler. These are discovery lists. These are lists that you can use to brute force subdomains. And then the last thing I would mention here is if you find commonalities between subdomains. So for example, if you find that you have webmail1.domain.com, try webmail2, webmail3. Try iterating them. Try commonalities to find more. But yeah, good lists are extremely useful. Okay, this is probably one of the first real cloud-specific items that's in this Recon so far. This one, basically, we're going to talk about MX records. So MX records basically point to where an organization's email assets are hosted. And a lot of times, if you just look up the MX records, which like I mentioned Recon NG earlier, there's a module for this that will just straight up point to these different domains, and they identify what service is being utilized. So for O365, you've got target-domain, which would be the company name or the company domain mail.protection.outlook.com. Same thing with Proofpoint, G Suite. You have these pphosted.com is the Proofpoint one, Google.com, Googlemail.com is the Google one. But basically, this helps us identify from a Recon perspective what security protections might be in place. So if I see that mail.protection.outlook.com is an MX record, I might change the way I attack a little bit. Same thing with Proofpoint. I might direct most of my password spraying directly at O365 instead of trying to hit just all on-prem resources. This is something that can kind of help us identify cloud usage. With Proofpoint, actually, so that's one of the things that I have noticed quite a bit that is a fun one for me now, because recently, I think it was DerbyCon last year, there was a talk where they disclosed some research that was done that bypasses Proofpoint spam filtering. And the way that it did it is they did basically machine learning on a bunch of emails that they sent through a Proofpoint gateway, and analyzed words that were kind of detected as being malicious versus the ones that were good. And they found that there was this list of 10 good words that you could just include in an email, and it would just give the email a straight up perfect spam rating. So it was good, even with malicious content. So by now you should have a pretty decent host list. We should have a pretty good idea of the services. There are some other services like Hacker Target, Threat Crowd, DNS Dumpster that help to kind of catch all in a sense. If you miss something, a lot of these catch other things that I have found that some of this straight up manual searching doesn't catch. They're good services. And then lastly, NetBlocks. So NetBlocks is kind of a beast of its own, I think. It's a lot of times not super straightforward because looking at who the NetBlock's owned by can a lot of times just be the ISP that the company is using. And so that doesn't really help a whole lot of times. Unless an organization actually has assets and IP addresses and NetBlock spacing directly assigned to them, it doesn't really help. But I will say this, the Aaron.net, the whois.aaron.net site that I have there, is awesome for finding more ranges that are hosted by a specific company. And specifically, the search bar is really awesome because you can just throw wildcards in there. So you can do like star, company name star, and it'll find any organizations that have registered an asset at Aaron. So it's great for finding other NetBlocks. So now that we've got this whole host list of subdomains, let's resolve everything and then compare that to lists of known Azure, known AWS, NetBlocks, GCP, and hopefully we can find and identify specific resources that are owned or that are being utilized. And a lot of times these are like the web servers and the things that the company is using for cloud services. So the Azure NetBlocks, you see these four links here. So the reason there's 4 different listings is because Azure has multiple data centers specifically for different services. Like, so public is like if you're in the US or anywhere else in the world that's not Germany or China, and you sign up for an Azure account, you get placed in this big public bucket of NetBlocks. If you're US government, they have their own specific bucket too, Germany and China as well. So these are the specific ranges. And after you get a credential, so after you authenticate with, like, let's say the AZCLI, you can actually figure out which place you're in via the CLI. AWS NetBlocks, they make it easy to just throw it all in one JSON file. GCP had to make it a little bit difficult because they they don't have like just a straight up public file that stays updated with ranges. Instead, you have to query certain Google text records to get the current ranges. So basically, here's a script that you can use to query the different Google NetBlocks. So this is straightforward. I'm not going to demo it because it just looks like this. But basically, to get the GCP ranges, it changes often, I guess. It changes more often than they want to update the JSON file. So anyways, if you want to look up the Google ranges, there's a script for it. By the way, this is one that Google provides. Okay, so cloud-specific usage part 2. O365 usage. So this is one of the main ways that I think a lot of pen testers and a lot of people who are familiar with finding if an organization uses cloud assets do this. So the first way is just, like I mentioned earlier, go straight to the O365 portal and try to authenticate with a target domain name. Okay. The other way is to look at these are 2 example URLs that will give you results like this. Okay, so like this first one, let me back up. This first one, the get user realm srf URL, it will actually tell you if the domain's federated. So for example, if you see namespace type managed right here, like that, then that means like password hash synchronization or the PTA, pass-through authentication, is in use. If you see managed, that means it's actually ADFS is set up. I'm sorry, if you say federated, it means ADFS is set up. And if it's an ADFS endpoint, or if it's an ADFS environment, it will also include the sign-in URL here as well. So without actually getting redirected from O365, you can see the sign-in URL for ADFS here. So let's see. For G Suite, same thing. So Google and GCP are kind of similar in that the sign-in URL it looks the same. They don't differ a whole lot. And so Gmail accounts can authenticate to cloud.google.com. And it looks kind of like this. And the cool thing about phishing with Google, which we'll talk about later, is that a lot of times, this little icon here, you can't see it, but if it's a valid email and it has an actual like icon associated with it, there's actually an API that gets hit to find that picture, and that'll happen regardless of if you're man in the middling or not. So if you're using like a framework like EvilGen X2, you can actually just point it at the standard Gmail portal and it'll load up their images like this. I mean, this isn't a good example because it doesn't have the image, but it, like, let's say it was me, it'd have a picture of me there. And so like the user that's trying to authenticate, that's being phished, can see that it's actually like the real account. Looks real anyway. AWS usage. Okay. So buckets, S3 buckets, are one of the primary things that I think that most people probably heard of in terms of being publicly exposed, publicly exploited. We're not going to look directly at buckets just yet, but what I will mention is that web applications and web assessments totally apply to this concept I'm about to talk about. So if you're a web application pen tester, if you do web application assessments at all, if you want to find if an organization is using S3, this is important. So oftentimes what you'll see is that static content is being hosted in S3 buckets. So you can actually host a website on S3, and you can host resources. What you'll mainly see this used as is just hosting like image files. So you'll see pictures being pulled from a specific website. So for example, over here, you see a browser visiting example.com. Now, if example.com has references to S3 for images, it can just straight up load them from there. So this would be something like, as you're going through your typical web app assessment, look for any references, any direct pulls from AWS, and specifically look for these bucket URLs. So anything s3.amazonAWS.com, s3-region.amazonAWS.com, those are going to be kind of what you're looking for there. For box.com, so I know this is kind of all over the place, and I apologize for that. But like I said, like when I built this, I kind of wanted to throw this whole methodology in, and this is one of the things that I like to look for because I have had some good usage with this specific thing. So with Box, you can find a company's login portal by doing companyname.account.box.com. You can find cached Box account data sometimes too that's just straight up available on Google. So there was actually an issue not too long ago where a bunch of cached data for, I think Apple had cached data out there. There was a few other companies just straight up on Box, or there's publicly available on box.com services cached by Google. And I've actually found a few out there too that's just like, why is this data public? Why is it cached? But it happens. So check the company you're targeting. Okay, employees. Employees is a huge category all of its own, right? This is something that, we could spend a day talking about doing open source intelligence, finding employees, finding who works at a company, what they do, thinking about good ruses to fish them, whatnot. For the purposes of attacking an organization remotely and for purposes of cloud attacks, we're going to mainly look at just identifying a good list of users so that we can do spraying with it, okay? Password spraying. Now, you got to build a user list first. So LinkedIn, still a good friend, right? It's super important to have a good user list. LinkedIn's a great resource. The only problem is that it changes. And actually, Justin is on. He has a tool. Which actually, Justin, do you have a link to that we can throw in maybe to your LinkedIn tool? Oh, is he on top of it? He's on top of it. Nice. So Peasant is in there. Yeah. So this is a good way to search LinkedIn users. Another potential resource is looking at Bing's cached data. So Bing will cache LinkedIn profiles as well. And instead of hitting LinkedIn directly, which they've done a pretty good job of preventing you from hitting it directly, hit Bing and just look at the cache data. Try to find employees that way, which Recon NG has a module for hitting the Bing LinkedIn cache search. The only problem with it is a lot of times it grabs like completely random data that you don't want. So it just takes some sorting through. So yeah, I saw a comment, wow, focus still around. Yeah, so when we look, this is metadata we're going to start talking about now. as an external attacker, you have generally an idea of what the email address schema looks like, because a lot of times you'll see marketing sites, you'll see things that have like contact us, and you'll see the format of the email address. The thing you don't always realize is the actual username schema for internal Active Directory users. Now, why that's important in the cloud sense is that sometimes you might want to authenticate directly to an internal like ADFS portal, right? Or I guess like a publicly exposed ADFS portal that utilizes internal domain / username instead of email address. This could be due to like a way they set up like UPNs and whatnot. So one of the best ways to find out those usernames is to look at metadata attached to these publicly available files. And what I mean by that is a lot of times what we'll find is that marketing, like Jason, create like brochures and things that they're trying to post publicly to help, talk about a product, or maybe we'll find like spreadsheet data of like annual report, like earnings reports, that kind of thing. They get posted publicly, and it's something that's supposed to be there. It's not something that's not necessarily not supposed to be there. It's something that these organizations are sharing. But the problem is that whenever it was generated, they utilized a piece of software like Adobe Acrobat or Word or Excel that attached their username to the metadata of that file. Now, basically what we're doing as attackers is just going and pulling down all these files. So we want to be able to just grab all of them and then analyze the metadata on each one of them. And if we can find an internal username in that metadata, that now helps us further our attacks, right? I know, Ian, you gonna do Banjo Crash something like that? Yeah, he's our marketing guy. So, determining username schema is super important for that reason, right? So build your username list with LinkedIn, your employee names, right? We're going to start with email addresses, mainly because we want to have that email address list for attacking cloud portals and whatnot. But we're also going to build these internal usernames, because it's not always obvious what the username schema is from the outside. A lot of times it's not just first name dot last name, or first initial last name. Sometimes it's 3 initials and then 3 numbers, and it's like that's not really something you can just like throw together without figuring it out. So I guess like the pattern here would be like we generate these users, and then we have to figure out a way to enumerate them sometimes too, which traditionally for on-prem environments, I would hit up like Exchange Web Services specifically for enumeration, because it has a timing vulnerability, which we'll talk about right now. So with O365, we've got a few different things we can hit, but with like historically, like for on-prem, like O and EWS, I used to use Mail Sniper, mainly because that would just hit EWS and we could enumerate users with that tool very easily. But as organizations are moving to O365 and eliminating on-prem OA, that's not really a thing we can rely on anymore. So the one of the newer methods that we found for username enumeration is at this at the typical login Microsoft.com authentication portal. So this is the Microsoft Online portal that is utilized for most of the Microsoft services. Now, there's basically an API. It's called the Microsoft Graph API that you're hitting whenever you attempt to authenticate to this endpoint with a certain client ID. Now, that authentication endpoint will straight up tell you if a username exists or not. It actually tells you a lot more than that, but for username enumeration purposes, that is what we're looking at here. So the goal here would be we build this list of email addresses. We use this username enumeration function to get an idea who's actually valid. That way we're not just like aimlessly spraying accounts that don't even exist, because that's a waste of time. We want accounts that exist and function really well for our sprays. The other thing is with cloud, I've noticed that there have been a number of other username enumeration vulnerabilities that have been found, but that have actually been fixed, which is kind of funny because, like Brian Furman, who's on, he knows very well because he wrote the timing attack module in Mail Sniper, and he knows that that is one of the things that was reported to Microsoft, and they're like, no, that's fine. But basically, the way that it goes is this: is if you have a valid account, the time that it takes to get a response from the application comes back way faster than it is if it's an invalid account. And it meaning in terms of time. So looking at how fast it comes back, you can identify if account is valid. So that the thing is there have been vulnerabilities similar to that on EWS for O365. So now the cloud version that have been fixed. So for example, I found one about a month or two ago where they had an X mailbox GUID header that would come back in authentication requests. So if you tried to authenticate, you would get this header back that said X mailbox GUID, blah, 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 blah. And it was just a random header, and that was one of the things that you could identify accounts with. I like how Cocoa Runner, and they've got the metadata out of my my PDF. Nice. And oh yeah, no, sorry about the author name there. So that basically brings us up to the point where we're going to start looking at exploiting misconfigured cloud assets. Okay, so we have up to this point we've built out our Recon, right? We built out the host list, we built out the username list. Now let's start looking for publicly available problems in cloud resources. So we're going to start looking at S3 buckets. We're going to look at Azure Storage. We're going to look at Google buckets. We're going to run a tool called Pacu, which is amazing for attacking AWS. And we're going to do some S3 bucket pillaging. So let's get into it. Okay, so simple storage service from Amazon. This is a service that is called, more famously known by Amazon S3, that allows you to store files. Across the three services, you have multiple things. You have Azure Blobs, you have Google Storage that offers a very similar way of doing these buckets. And the thing is that it's technically secure by default, okay? And what I mean by that is it's actually really freaking hard to make these things public anymore. Amazon, I spent, I don't know, half an hour yesterday trying to make a public S3 bucket. Because they basically make you click a checkbox. You can see it in the screenshot here. So that box is checked by default. You set up an S3 bucket. It says block all public access. I'm not going to let anybody access this. So you have to click that one first. And then down there at the bottom, you have to click that second one that says I acknowledge that the current settings will result in this bucket, being public. And it's okay, there's two steps right there that I have to do to misconfigure this to be public. So the thing is that configurations still happen. Configuration issues still tend to happen. And a lot of times it's not that somebody's necessarily just, on purpose trying to be really negligent about how they're hosting stuff. A lot of times it's that, for example, I mentioned the web application thing earlier. So getting the web applications hosted might be like part of the process for hosting that data might be using S3 buckets. Might be something that leads to these configurations issues being a problem. If you want to look up specific regions, and SLOOKUP can kind of help with that, but most of the time you don't really need to worry about the region anymore. We're going to get into S3 buckets a little bit more in a minute. The next thing that I want to talk about is EBS volumes. So EBS volumes are elastic block storage. So this is different from S3 in that S3 is more like your typical file storage for anything. EBS are really like your AWS virtual hard disks. So these are the things that get utilized by VMs and whatnot. There was a talk at DEF CON 27 by Ben Morris from Bishop Fox, and he wrote a tool called Duffelbag to search this data. Now, these can have similar issues to being public. Okay, so your S3 buckets are pretty easy to find if they're public because there's basically ways to enumerate that data. The problem with EBS volumes is not really like searchable in the sense that you can find them because of the nature of how they're built. So to actually look through a snapshot, the other thing is like there's like petabytes of data to look through of public EBS snapshots. So it's difficult to target a specific org, but you can find widespread leaks if you just start searching. If you start running duffel bag, you can start looking through some of the data. So I'd recommend if you want to just like research some of the EBS stuff, watch his talk, run the tool. But so the problem with actual EBS volumes is like to look through the data, you have to like copy the EBS snapshot, you have to instantiate a new volume from it, you have to attach the volume to a running AWS machine, so you have to have a machine to attach it to, then mount the file system to search it. So it's not like the super intuitive, like fast thing you can do. But anyways, I want to throw that out there because it's important. Public Azure Blobs. So this is very similar to S3. So think folders, right? Like think, a company that wants to host a file, they can use S3 or they can use Azure Storage. It's for unstructured data. So there's containers and blobs, okay? So containers are pretty much like the folders that blobs are kind of stored in, kind of like an S3 bucket is like the main entity, and then you have like the data stored within it. There's predictable URLs that can help you identify if there's a storage account, okay? So in Azure, you have to actually have a storage account before you can actually post anything. And so the storage account, whenever you generate it, creates this domain name. So it's storage account name .blob.core.windows.net or file, table, queue. There's a few other ones. There's database if you have databases that you're utilizing. But basically, we're going to explore a technique for finding these that was documented by NetSpy. So Carl Fossean wrote this tool that we'll be looking at. The blob access policy essentially means that anybody, like, so if you look on the right here, you have, like, whenever you create a container, you have the name, obviously, but then your public access level you can choose from. And if you look at the different roles here, you have private, obviously, which means like there's no public access that gets set. You have blob, which means there's essentially like anyone can read the blobs, but can't list the blobs within the container. That makes sense. So like they can access them if they have like a direct link to it, but they can't actually list them within a container. If you set container, that means you have anonymous read access to both the containers and the blobs within the containers. So this would be like the worst case scenario for somebody that had set up a bucket like this, an Azure blob like this, because this means that if I can enumerate the service account, the storage account name, as well as the endpoints, then the containers, I can list out anything within it. So Microburst is the tool from NetSpy that has an awesome module. It's called Invoke Enumerate Azure Blobs that does this. So it'll brute force the storage account names and looks for potentially like sensitive data that somebody's posted into blob storage. So this will straight up brute force the account name, which in my screenshot here. So I set up this one. Glitch Cloud is my test environment for this. Okay. So the storage account is glitchcloud.blob.core.windows.net. So it'll brute force that using various permutations. So it'll add on stuff like -dev, like other items, storage. It'll add on words, and you can give it a list to add on other things to try to brute force this too. So it'll find those, and then it will search within those to see if there's any public containers as well as files. So in this example, it found the container called confidential within the storage account Glitch Cloud with the public file of secret.txt, which is in the confidential folder. So Google Cloud Platform similarly has a storage service. It's called Buckets. I mentioned Chris Moberly earlier and his research into offensive Google Cloud stuff. So he has a tool called Cloud Enum that actually is amazing for all three services. So your S3 buckets, not only just buckets, it actually finds like databases on Azure, finds VMs, web apps, because a lot of those just create that general domain name. So I honestly, like, this is probably one of my go-tos, like, initially, if I want to just find them on all three services. And basically what you do is you just supply like the name of like the domain or whatever. Like, for example, like on the screenshot here, I ran it and I just gave it the name net, and it will go and it'll try to find all these buckets. So you can see like protected Google bucket at, storage.googleapis.com/Netflix. And it'll tell you if they're unprotected as well. Okay. All right, Pacu. So Pacu is the go-to AWS exploitation framework that is from Rhino Security Labs. Like if you've ever looked up or you've searched for anything offensive related to AWS, you've probably stumbled across some articles from Rhino. And basically they've created a number of different resources for learning both about AWS vulnerabilities. So they have flaws.cloud, they have Cloud Goat, which is a tool that sets up vulnerable like scenarios within AWS for testing. And a lot of those you can use the Pacu modules against to learn how to use Pacu. But essentially, so Pacu does bucket discovery. Okay, that's one of the many things it does, as well as a number of other privilege escalation attacks, and then straight up like enumeration of what access you have, few persistence modules. We dive really deep into the privilege escalation and persistence modules in the next class. But yeah, no, I think I like Cloudinium if I want to discover buckets like on a wide range. But Pacu is definitely the go-to for AWS specific. Okay, so we're at our first lab, guys. Let me go ahead and switch over here, and I will walk through a lab with you guys. All right, so for this first one, we're going to be using our Kali VM. Okay, so the goal of this first lab is to locate Amazon S3 buckets. Okay, so let me see if I can bring over this. I'm going to try to bring over the slides so you can kind of see those while I go through this as well. I know it's probably not the most ideal size-wise, but we'll see if we can make it work. Is that looking okay? Anyone? Brian? Anybody? I'll try to kind of make this work so we can kind of have both here.
Yeah, I can see it. I mean, it looks good for me, but anyone at Discord who wants to comment on whether or not,
Yeah, it's looking solid my way as well.
Okay, sweet. All right, so the goal of this is to locate Amazon S3 buckets, and we're going to try to search them for data. It's pretty straightforward. This is something that I think is, while I pointed out that S3 buckets, it's kind of hard to, like these days, to actually like make them public. It still happens, and this is something worth trying. So we're going to go through this and see if we can find some public data. All right. So like I said, the first two labs we're going to be using the Kali VM. The first thing we're going to do is install Pacu, which to do that, you're going to want to just run this. If you have the slides, you're going to want to just copy and paste commands out of it. But basically, you're going to want to run sudo apt-get install python 3-pip, which will help you get the pip tool needed to install Pacu. And then you're going to git clone the Pacu repository, which I've cloned down here. And then once you're in the directory, so you do cd Pacu, then there's an install sh file that will install Pacu for you. So basically, you just run sudo bash install sh. I'm skipping this because I have already done this, but if you have not, then this is time to do it. Next, you're going to want to set up AWS keys, right? So basically, like to set up AWS, so the AWS CLI gets installed with Pacu, and you have to use keys to authenticate to AWS to do searching. Okay, and those keys are the ones that I basically had you guys sign up for AWS accounts earlier. So what you're gonna want to do is basically run sudo, because we're gonna run Pacu with sudo, and so we're gonna want our keys to be accessible as root as well. So sudo AWS configure, and then enter your password, and then so here, see, I've already set mine, but basically here is where you will set your access key and your secret key. So you start with the access key, and then you'll do your secret key, and then you don't really need to put anything for region and format. So like I said, like I know this is kind of going quick, and I apologize for that, but just try to focus more on the techniques, and then maybe try to actually go through it on your own time, because this is all self-contained. Okay. But if you guys got the slides, you'll have all these commands, so you should be able to kind of do these on your own time. Okay, so now we're gonna start a Pacu. All right. So to do that, we're gonna run sudo python 3 pacu.py. And whenever Pacu loads up, it's going to ask you if you want a new session. So this is just basically a way of changing or storing different data for different sessions. Like if you have different companies you're testing, so you could do like test, for example. So we have a new session called test, and it will print all the help instructions right off the bat if you want to go look through those. I know it looks kind of jumbled here because of the way I have everything kind of big. So the first thing we got to do here is we have to import our keys. And so Pacu leverages your AWS keys that you have put on disk. So if we do import keys, I have --all in there in the slides, but if you just do default, it'll import your default keys. But --all will import all keys. I have like 4 different ones on here because I was testing for another portion of the class. So I'm just going to import the default key for the sake of this, but --all should work. This is a brand new AWS instance for you. So one of the things you can do, and that I think is kind of cool, is like from Pacu, you can just run AWS CLI from here, right? So you can do like AWS, like STS get -caller identity to list out your account number, and this kind of helps you get a better idea of who you are. Because like let's say you get keys, right? Access keys, secret keys. It's not super obvious who that is, right? A lot of times, because it's just a number. But here you actually see the username is test of this user, and we've also got the ARN number here, which this is the account number of the actual AWS account itself, which is useful for a few different things later on. Go to the next slide. Okay, so like I said, there's a bunch of different modules. Here, let me see. List is just list, I think. Yeah, so if you run the command list, it'll list out all the modules within Pacu. And you can see here there's a number of different modules, right? You have Recon, unauth Recon. You have enumeration of the account that you're authenticating as. So for example, like you can enumerate EBS volume snapshots. That's like one of the things here. You can enumerate. You can detect honey tokens. This is kind of cool, right? So like if you stumble across some tokens, you might want to run that first to make sure that the tokens you have aren't honey tokens. EC2 enum will try to identify EC2 instances that are available. And we've got a number of IAM modules. They're separated by the service, right? So IAM is all your identity stuff. So getting if your credentials or whatnot. And then EC2 is all the EC2 stuff and whatnot. You have this single escalation module, which is awesome because this is basically like a vulnerability scanner that looks for like 20 or more different privilege escalation vulnerabilities. It's really awesome. So I have a question. Do the account owners ever get notifications about enumeration attempts on their accounts? So that depends on the level of logging in place, right? Because if you have just keys, generally you're not getting alerted to access from that. I mean, so Pacu, I think it detects by default if you're on a Kali box and will change your user agent. Let's see if it's set that. Because the guard duty function of AWS will alert on specific user agents like Kali. I think Pen2 Linux is another one. But I believe that it changes your user agent. Yeah, right here. So check this out. Detected environment as one of Kali, Parrot, Pen2 Linux, modifying your user agent to hide from guard duty. So that, it's one of the things Pacu is trying to help avoid, right? Is getting detected. So, okay. Let's enumerate some S3 buckets. So now, basically, we're going to run S3 bucket finder module against this domain glitch cloud. So this is one that I set up to have a public facing S3 bucket. So if we run this, it's going to say, hey, it requires this external dependency of sublister, right? Which is fine. That you need to use sublister. So yes to install sublister, and it'll install the dependencies, and then it should go forth and find us some S3 buckets. If it doesn't freeze on me. There we go. Okay, so what you're seeing here is that, here, let's see if we can bring this over so we're better. It's finding the listable bucket glitch cloud on these different resource groups, right? Or on the different regions, I should say, different regions. Come on. It's getting there. It's getting there. Finding them slowly but surely. The problem is that, it's like 1,000 people are all trying to list this bucket at the same time. Which, honestly, this is an interesting test. I wonder if Amazon's going to fall over. Probably not. It's probably going to be fine.
Didn't Anonymous once try and knock Amazon over and then didn't? I think I remember that. So I don't think we're going to hurt
Yeah, we're
it.
probably fine.
Yeah.
Hope so, at least. So we'll let that finish up. I'll move on to the next slide. The grave, yeah. Okay, so number of buckets, 34, listable buckets, 34. So that's a good indication, right? That now let's go find if there's data out there. So one way to do that is using just straight up the AWS CLI to do ls like you would in a typical Linux command infrastructure, right? Like ls to list files on the S3 bucket. So now if we try that, we should be able to list out any files that are there. And we can see, okay, we've got a credentials and an index.html file. So let's go see what the HTML file is real quick. Come on, web browser, open. Let's go, Kali. Maybe I should have given it more than 2 gigs of RAM. Just kidding. Should be fine. So basically what we're going to do here is go to the S3 domain, which is the company name, right? glitchcloud.s3.amazonaws.com. So that should just basically load up and kind of show us what we've got here, right? Like, so we can see the credentials file, we can see index.html. So, like I mentioned, like you can straight up host web applications on S3 buckets. So like there's index.html. Hosting here seemed like a pretty good idea. But now let's say we want to let's say there was a bunch of files, right? Like we had a ton of files. Like we had, I don't know, like 300 files out here. That's not super easy to just go through, right? Like on its own. So let's actually just go sync all the data down to our own local file storage. So if we do AWS S3 sync S3:// glitch and then give it like a folder name. So you can call it like S3 files dir. That'll create a directory in your local system. And since it's listable, those files can just be straight up copied, right? And so now I should have a folder called S3 files dir right here, right? So now if we go to the S3 files dir, we should be able to just straight up cat out credentials. Let me make this a little bigger. And you can see in the credentials file, we've got an access key and a secret key. Obviously, these are examples, but the whole point here is that, we've got the potential for web applications being hosted on AWS. We've got the potential for mistakes like sensitive data being hosted on S3. And this is kind of just an example to kind of give you, something to look for, right? But that's pretty much it for this lab. So there's only a couple more slides in this section. It might go like a couple minutes past the hour, but I'll try to keep it relatively short so that we can end this prior to hitting that hour break. Oh man, wrong one. I hit start from beginning. Not the right thing. We want to start from slide 61. There we are. Okay. So we talked about S3 buckets being a form of us accessing data. Now, what if we could put data there? That makes this way more interesting, I think. So back in March of 2018, there was a crypto miner malware that was being straight up hosted from MSN's homepage. So you would go to msn.com and your browser would start mining cryptocurrency. And people were freaking out, like, how the hell is this happening? And basically they found that it was due to AOL's advertising platform having a writable S3 bucket. So AOL's advertising was being hosted on msn.com. AOL had this public writable S3 bucket that content was being pulled from. And essentially what was happening is that the attacker just posted some malicious JavaScript within that publicly writable folder. So when you're on an assessment, like the thing we're looking for is, can we actually find any of these writable directories? And like I mentioned, web app testing earlier, this is another thing which kind of applies. So if a web app is loading content from an S3 bucket, we can straight up execute malicious JavaScript now because it's pulling that resource from something we can control. So imagine this. Imagine we find this S3 bucket that's being hosted publicly. We find that we can write to it. We find that we're assessing this web application. The web application has these calls to the S3 bucket that it's loading these JavaScript resources from. All we have to go do is go modify that resource that web application is calling, and now every single person who visits that web application has our JavaScript running in their browser. So you can perform, cross-site scripting type stuff. You hook their browser with Beef. I mean, again, like this is one of those things that it takes effort to do to make it public, to expose it. But like this is what the permissions kind of look like in AWS. So you'd see like everyone has public permissions of read and write. This is something you have to straight up explicitly set for that bucket. And one of the things you can do to test if you can write is just this AWS S3 like move, like you're moving a file to that S3 bucket. So like essentially what you would see here is like I would have my malicious JavaScript locally, and then you would point it at the glitch test or whatever your target S3 bucket is. All right. So domain hijacking is another one that is kind of similar to what we were just talking about, but it also relies on utilizing S3 buckets for a more offensive purpose and hijacking. So now let's say we're going through a web application assessment and we find that it's trying to call resources like images from a third-party site like AWS, but we're getting 404s. So it's things that used to be there, things that are not there anymore. Potentially, one of the things we can do is straight up hijack that bucket. So now, while you go through analyzing web applications, start looking for 404s to s3.amazon or amazonaws.com, because one of the things you can do is go and just register that bucket. Like maybe it's an old thing, like they deleted it, and we can go through and add it. So the same thing. This is a very similar similar issue. And yeah, we're going to take a break in just a second. This is going to be the last slide, and then we'll do a break. The same thing with brute forcing subdomains. If you find an org that has this 404 error, this says no such bucket. Okay, so let's say that we've found all our subdomains and we ran something like eyewitness against all the subdomains to screenshot everything. And we find that we're getting these 404s that say no such bucket. That means that domain, that actual CNAME, was pointed at a specific S3 bucket that doesn't exist anymore. Okay? Now, if that's the case, the same thing applies. So we can go register the S3 bucket that it's being pointed to, and it'll straight up tell you bucket name, blah, 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 like it would be right here, is something that it can't find. It says, there's no such bucket because maybe somebody set up a domain, maybe they had their web application hosted there, maybe, I don't know, some sort of other historical issue like made them take down the S3 bucket, but didn't change their domain name and the CNAME that's pointing there. So one of the things you can do is just go register the bucket name, and now their web application, their domain is pointing at your S3 bucket that you own, that you have full control over, and you can host whatever you want there. I mean, imagine like the phishing possibilities of hosting a payload on a domain that's signed by them. I mean, there's just so many possibilities for really bad stuff here. So yeah, so look for 404s. Like I know that's like one of the weird things. Like on pen tests, we're not really often looking for 404s, but this is like the one rare case where you would want to go do it. Okay, let's take a break, guys. Let's give it 10 minutes. So let's do 12 minutes past the hour, and we'll come back. So feel free to go take a break, grab some coffee, and maybe we can answer some questions here. I think Jason had to hop off for a minute. He texted me.
Beau, how you doing, sir? You're killing it. You gonna take a break this time?
I'm good, dude. I'm good. I'm gonna hang out.
Well, high five. Let's get you some questions then. The first
All right.
one is, are you going to cover cloud container attacks in your 16-hour class?
Yes, a little bit. So we'll do some little bit of Kubernetes, a little bit of Docker, a little bit of just various like cloud hosted containers. Yeah. Not terribly a lot, but yeah, some.
Excellent. Good to hear. How about OpenStack? There was a specific question about OpenStack clouds.
No, I don't have anything about OpenStack in the clouds.
Okay, 10.4. Here's an interesting one. With an increasing number of API and microservices that on cloud resources and them getting exposed to the internet, do you recommend any specific list of best practices to ensure the APIs are secured, right? So this is flipping that around and looking from the blue team side. What are some of the best practices for securing your APIs you expose on these public clouds?
So multi-factor is probably the primary thing, right? Strong passwords is the other thing. For the APIs, right? I mean, things like your programmatic access to AWS. I mean, there's not a whole lot of like two-factor you can do for that, right? You just have the keys. So that's tough.
Yeah, we use some AWS STS, so they have a token service, which is awesome, which you can use to run 2FA in your code. But yeah, I'm where you are, right?
Mm-hmm.
Strong passwords, standard hygiene best practices, putting stuff behind load balancers where appropriate. Yeah.
Right.
Next up, what is the best way to connect from O365 with a service account from an on-prem server for pulling down data?
Oh, we had that question.
JSON keys.
Yeah, we answered that one in the first break.
10.4. Okay, here's another one. What about corporations that use a third-party authentication provider like a Jump Cloud or similar for AWS Management Console? So seen a lot, and any tips for navigating these situations?
Like an Okta kind of situation?
Yes, exactly.
Yeah, like some sort of SSO, one login, Okta. So actually, Derek and I have a really good example of how that can be useful.
Your Okta pen test is one of my favorite reports, man. It's so beautiful.
That's one, but there's just last week, Derek and I, he called me in to help him with an assessment he was on, and they were using one login, which so with regard to accessing the management consoles, like things like Azure Portal, things like AWS Console, you typically would want to have it redirected to your SSO portal, then authenticate you, then give you a token, then give you access to this other portal, right? So the thing that Derek and I found was that O365, Azure's portal.azure.com was protected, but we were able to authenticate via command line with PowerShell without being redirected to that SSO service, which actually, in fact, was a complete 2FA bypass. So the thing to consider is whenever you implement these things is the thermal exhaust ports that are also not protected by the service. So I would say that have a really good understanding and talk to whatever provider you have to make sure that they know what you need to do to protect those other portals in other ways in. Does that make sense?
Excellent. Have you seen the robot chicken about the thermal exhaust port? Because that's one of the funniest scenes in Robot Chicken history.
No.
Okay, fair enough. Here's a question. I'm not sure exactly which API the commenter was specifying, but it basically said, is this API not protected by Microsoft for bot and enumeration traffic? And I would say that's probably more general to any cloud. You expose an API, what onus is on the provider of the API, right? The platform itself to protect us from enumeration and bad traffic?
Yeah, so that's a good question, right? I mean, so AWS has services. Azure has services to help prevent things like password spraying. So what we're about to get into, actually it's coming up very soon, is password attacks and password spraying. And one of the things that I'll talk about is smart lockout policies, which smart lockout is a service that Azure offers for that specific thing, right? It actually will detect if you've authenticated from the same IP address 10 times and will start locking out your IP, which it's not an end-all be-all, right? Like if it's just an IP-based thing, but I think that there's a lot of weight put on people who are deploying their own stuff, right? And I don't think there's a whole lot of help from cloud providers.
Absolutely, and I think what you're looking for there is shared responsibility. And when you go purchase these services, you got to look where you are in that shared responsibility stack. Like, am I deploying a service that is 100% my responsibility to secure? Because like AWS will give you security for their data centers and their handling and operations of the hardware, but they're not going to say you are secured by us running through our API.
Right.
So there's a lot of onus on the people who are deploying solutions on these clouds to understand where they are in that shared responsibility model.
Mm-hmm.
So okay, next up, S3 module. The S3 module we're looking at in Pacu primarily looks for listable buckets. What do you usually do when listing is denied? Can you give some recommendations regarding permission enumeration and object brute forcing for blind downloads, uploads? And I guess on this one, I would say, have you ever used Grey Hat Warfare, Beau? Because they do a lot of effort on this.
They've like pre-scanned a lot of stuff, right?
Yeah, it's definitely a paid tool, but it's a tough one.
Yeah, I don't know. You know, for cases where buckets aren't public, I mean, you might have to just move on to one of these other techniques.
Agree. Let's see. S3 bucket name is unique. This is back to one of those last bullet points you had, which was awesome. I'd not seen that one, the 404. S3 bucket name is unique. Is that the same bucket displayed by Pacu tool in multiple regions? So I'm not sure exactly what that's saying.
Yes.
Okay.
Yes.
Cool.
They should be the same bucket. So like when you register a bucket, you have to give it a unique name. And so when you deregister a bucket, it just deletes it, and people can now re-register that new unique bucket. If that makes sense.
Okay. Someone is asking for a wallpaper of your slide background. Share at your leisure, sir.
We can do that.
Here's another one. I kind of like this question too.
I made that.
Of the 3 Azure authentication methods, which one are we finding the most frequently on engagements?
It's been pretty much 50-50 between password hash synchronization and ADFS. I think it's literally like 50-50, like pretty much like right down the middle. I don't know about you guys, but
okay, yep, I would agree.
For me, it's been pretty much 50-50.
Let's see. So what about Azure? Best method for collecting logs from there. So I would say like Azure Sentinel is awesome, which is kind of like Amazon Guard Duty. But you also have to make sure that all of your API calls are being logged, which basically any programmatic change to Azure, to AWS, to Google Cloud is an API call.
Mm-hmm.
As long as those are logged and you implement the security service that sits on and parses those data sets, you're probably good. But I don't know. What are your thoughts there?
Yeah, I mean, same thing. I worry about things that are getting missed. And the main reason I say that is because I've noticed, like I said earlier in this talk or in this training, that I found that service principals authentication does not get logged by Azure. So if you go authenticating to Azure with a service principal, it does not log it. Like, I mean, actions you do after logging in do, which that can generate alarms, right? Like, so for example, if I log in with a service principal and create a new account, like that gets logged. Okay, but the actual authentication doesn't. That make sense?
Yeah, exactly.
It kind of makes me worry a little bit.
Wild problem. All right, last question. And this might be CloudFront from my perspective, but maybe not. Can you name some ways an attacker could utilize CDNs for further attacks? And I don't know if we even consider CloudFront. Are they a CDN of
domain
sorts?
fronting, dude. Domain fronting.
Yeah.
Yeah. So I primarily just use CloudFront for domain fronting. So if you're not familiar with domain fronting, essentially what it is the ability to do C2 traffic to a CDN provider like CloudFront, like Azure. Azure has its own CDN. And basically, the thing about domain fronting, it makes it really hard for defenders because the traffic looks like it's going to a valid domain, but the actual host header that's set in the web requests for that C2 traffic is to a CDN domain that you control. So if you set up CloudFront, you have the ability to create like your own personal CDN domain, and basically you point the host header of that CDN, and I'm explaining this really terribly. If you have a service that you know is hosted on that CDN, so if you have, like, you can use Steve Borosh, Reverse Shell. He has a tool for finding domain fronting or domain frontable site. You could run that and find certain things that are hosted, like, for example, like ajax.microsoft.com is a really good one that's on Azure. You can make your web C2 traffic look like it's going to ajax.microsoft.com, but it's actually redirecting on the back end via the CDN to your own C2 infrastructure. So that's mainly it. Looks like we're...
Cool. Hey, thank you.
Hey, there's been a question in Discord asked a couple of times now, and I was going to answer, but I thought I'd let you answer. So bucketname.s3.amazonaws.com and Azure Blobs subdomains, is it typical for orgs to try and map C names to S3 buckets and blobs to obfuscate origin, and is there an ideal pattern to identify those?
That's a good question. I think that trying something like the Cloud Enum tool will help you find those anyway. Actually, you know what? Let me do that real quick. Let me just show you that real quick, because I think I have it on here. The thing that you're talking about is basically the functionality of permutating the name that you're looking for. So, like, while this is not a lab, I want to show you guys this real quick because I just think it's really cool. So Python 3 cloudinum.py, and then I think you just give it -d, and then, like, I don't know, like Netflix. Oh, it's not -d, it's -k for keyword. Sorry. So you'll see the permutations here. So like you see like Netflix 001.s3.amazon.com, AWS.com, Netflix -01. So those are permutations, right? And that's basically what you're talking about when you look at like mapping names to a specific organization. You're going to want to try running a tool like this, running a tool like Cloudburst that does the same thing for the storage accounts in Azure, and you'll possibly find some of these different buckets. Okay. All right, moving on.
Hey, Beau, sorry, one more question. How long will Glitch Cloud be up?
Oh yeah,
after-
I'm gonna leave that up. I'll leave it up for a while.
Okay, thank you.
Until, as long as I don't get like crazy AWS bills from everyone just like pulling it down all day, like then we should be good.